All right, in our last lecture on open channel flow today, we talked about hydraulic jumps and how flow profiles are created. Now, what a flow profile is the definition of how depth varies along the channel. And for most of our calculations in rapidly varying flow, this is simply the solution of the cubic, which is to say that E1 is equal to E2 plus delta Z. And then this allows you to solve for Y2 as a function of Y1, the channel width, delta Z, etc. Important point here is you need to choose sub or supercritical it's sliding around. Let me pause. So the sub or supercritical conditions need to be based on upstream conditions. In other words, if it's subcritical upstream, we try to keep it subcritical as it goes over the obstruction. Can't go through all of the examples that we talked about today, but if the flow is supercritical, that is, the Froude number is greater than 1, and if the energy is insufficient to get past the obstruction, to get past the delta Z, then a hydraulic jump occurs. Again, I can't go through all the different examples that we talked through today. If we have an obstruction here, one example would be a supercritical flow. I'll draw this in blue. Supercritical flow that undergoes a hydraulic jump. It then gets deeper, and it goes over the constriction right at YC. We have this Y1, YA, and then this might be, say, YN for this channel. This is an A. Going from YN to YA, you use the hydraulic jump relationship. We don't worry about the variation from A to 1. That's a gradually varied flow solution. And then here we have conservation of energy, or E1, is equal to EC plus delta Z. If the flow was subcritical on the approach, it wouldn't have to go through the hydraulic jump. It would simply follow this solution all the way back and then go over the critical. If the energy was sufficient for it to get over the bump, it wouldn't have to be at the critical value. This could be some other depth greater than YC, in which case there'd be no need for a jump, and you would solve for Y2 based on the upstream conditions. Please look at the 4 cases that I talked about in lecture today. Essentially subcritical versus supercritical upstream. That's the upstream condition. And then whether the energy is sufficient to get past the obstruction or not. Those 2 options on each of those 2 parameters define 4 cases that we can sketch the solutions for.